So there we go, middle of the day. Solar charger is running at full capacity, 20 amps, and that's fine. So 10% in a couple of hours. Got 20% left, so another 2-3 hours. It's done. So yeah, this has worked really well. Just run off these, I guess, car batteries. Inverter, solar charger, controller, 4G internet run from the batteries, and it's completely separate, not connected at all to the mains downstairs. The only thing that is the hot water heater, and that's it. The oven is gas. There's a microwave that runs from it, coffee machine, obviously the TV. Yeah, that's it. Good morning and welcome back. So on the last one we just started putting the boxes on the wall. Let me just show you how far I've got. It's taken a while because I've just got so much other stuff to do, but this is where we're at now. We have here, this box will be for the control unit. So I'm going to mount that later today and you'll see how that'll look. This box here will be the input from here of the solar panels. So they'll come down in cables into the top here. And we will have, what do you call it? Lightning protection devices. There's 2 rows of panels, so I'll have 2 of those. And then 2 isolation switches for the solar panels so I can turn them off. And when you're dealing with solar panels, the power provided from the solar panels is DC, direct current. The difficulty now is using the correct thickness of cable. Let me show you why. Here's one I prepared earlier. And this is a 50 square millimeter cable, and I need 2 of these in red and 2 in black to go and power the main multi-plus inverter as per the manual. And a lot of people under cable their inverters, so always read the manual and use the correct thickness cable. Saves burning the house down later on, obviously. Okay, so I'm just installing the fuses inside one of these fuse holders, which will take the batteries. Yeah, so that's, let me just show you how we do it. So I've slackened these off. So inside here, hello, is a shake-proof washer, another metal washer, and obviously the nut. And the way this works, take the bottom one off. I'm doing this one-handed, by the way. Take our mega fuse, put it on here so that the flat plate has good contact with that. And then we have a flat washer, shake-proof washer, and a nut like that. There we go. So how tight? Well, get yourself a little, this is just an Amazon Basics. Now before anyone says get an insulated one, yeah fine, if I was doing these all the day then I would, but take the risk myself, because if it's got a metal tool and you cross connections and you don't know what you're doing, then there can be problems. But I accept that. I'm not going to pay £1 million for one when One from Amazon for $9.99 will do the job if I'm careful. Moving on. So then you use a mini torque wrench set to the required tightness, like that, and you know these are set at the required tightness. And we're going to be doing that a lot on this system, especially with the DC connections. And the reason for that is loose connections are the worst, or the biggest enemy of these kind of systems. There's a lot of current being passed between cables and bars and devices, and if that connection is loose, it increases the resistance, heats up, and eventually sets on fire. If your protection systems aren't any good, then you know it could be very disastrous. So we're going to make sure everything is the correct tightness. I'm not going to say what they are or what I'm doing them to here. That's down to you to check. All the information is available, especially with the Victron stuff and Fronius, right down to the screws in the casing. So it's all there. So that's it. I'll put the rest of these in. So this is the battery section. So the cable's going to go through here into here and then be bolted on. So the positive goes on the top, which is fused. Then underneath you can see is the negative, which goes in there. You have the two cables coming out the bottom. I've just got to decide how to make this look the best. So I'm going to connect those up and then bring you back. A whole day and it looks like I've done nothing. Anyway, good evening. Let me show you what I've been up to. So the battery cables are in. And we go down there into the conduit and up and into the distributor. Let me open that and I'll show you what's happening inside. Okay, like we said before, you've got all the positives going through a fuse to a main bus bar, and the same with the negatives underneath onto the negative bus bar. So this is it. So the output of all four batteries are parallel here. That means the power of every battery is now transmitted onto these two bars here, and then we'll go this way into another unit, same as this. That's taken ages. What else have I done? So now we can see inside. Let me just adjust this. We can just see inside our main inverter. Really simple, nothing super complicated. Let's have a look. So we have on this side AC out 1 and AC out 2. AC out 1 is when this converts DC into AC, it comes out of there. AC out 2, look. AC out 2 is more or less just a straight connection to the mains, to the grid. So it doesn't use this, it just goes straight to the grid. AC in is the grid connection, so you take it from here along and up straight in there. And then, because this, don't forget, is a charger as well. This side here, 4 connections, but they're really only 2. These two are connected together, these two are connected together, and they are the battery connections. You can see that's red, that's black, so you've got positive and negative, and they go through here, into here, all the way around. Well, in fact, I'm going to put another conduit there, but they come in here, all the way around, and connect onto the distribution version of this. We'll get there in a minute. It's so complicated. We'll get there. I've also made this, which is to house the control unit, and that's fixed in there now. So we're just waiting on a couple of things to arrive in the post, and then we can carry on. Good morning, everybody. Welcome back. What we're doing now, we are connecting the data cables. Let me show you. I'll show you. These batteries currently, the batteries are all individual, but they all terminate at the same place. We did the other time, just previously on the videos. What we need to do now is make these batteries work as one. So in order to do that, we join them from here to here to here to here, so on. And they provide the cables to do it, but the cables are long and the plugs are massive. And when you put this plug in here, the doors do not shut. Stop. So these are straight through cables. There's nothing specifically amazing about these cables. So what we're going to do is make our own. And to make it look good, we're going to make it from flat cable. These are just straight through cables. So standard patch cables like I'm used to working with over there. So we'll make one, I'll put it on the tester, make sure it operates correctly, and then put it in, and you'll be able to see all of the cables when they're done. See you shortly. Okay, I made my first cable, just testing it now, and you can see there's something wrong on the right hand side. Look, let me slow it down for you. There you go. So it goes 8 to 7 instead of 7 and 8. That's why it always pays to double check. I could have put that in and wondered, I would have been spending hours trying to figure out why the batteries weren't working. I've got to say, if you can use it, use the original cables that come with it, obviously, but we can't in this situation. So I'll just make another one. I've got enough cable, I'll scrap that completely and start from scratch. Take two. Have a look. Perfect. So now I'll do this one-handed, just for you. This is going to be, the reason I picked green is because in France all the data stuff is in green conduit. No other particular reason other than that. Yeah, so let's have a look. So this should go in here, and then I've actually done a little twist in the lead. Oh, sorry. Start that again. So this goes in here. There we go. And hopefully this one should go so that looks pretty neat. We know it works because we tested it. There's two more of those to do, so it won't take too long. And then this allows the door to shut, no problems, and it's going to look quite nice with the green. Unfortunately, the earth cable, I can't do much other than tuck that in quite neatly. That's it really. So once I've done those two, I'll come back to you. Done for this part. That looks quite good, quite neat. quite like the green. So now we need to go from there down into the trunking and up to the control unit in the top there. This cable is a special cable, so I need to check what connections go where to make it work with the Victron Cerbo. The Cerbo is the control unit, but the pins have to be correct. So although the control unit up there can talk to it, it has to be the correct pins into the top. So stand by. Okay, a little explainer. The batteries connect to the Cerbo using a protocol called CAN bus. Now, most of this make of battery, the Pylontech, it uses the B type, but the 5000 series uses type A. So what you need to do is find out the correct pins for the battery to communicate with the Cerbo. The information is available on the Victron website actually. I'm going to do it in green because it looks nice, but you have to make sure that the cable works properly. Let's give it a shot. What's the worst that could happen? There we go. Top one is connected, runs through the back, down here, up in the conduit, and then into that. So I'll get the connections in and see if it's possible to power up the control unit and the batteries for a test. And if that works, I can register the control unit and then start adding the other devices as and when we connect them. Right, so let's have a look. This is the power lead for the Cerbo. Can run straight from 48 volts, and it's separately fused here, inline fuse, and it's designed to go direct onto battery terminals, which is that there. However, the obvious thing is it's just a bit too short. Like everything in life, it's just not quite right. I'm either going to extend this cable if I've got any of the same, or I'm going to replace it for something the same or better and keep the inline fuse. So let's have a look. Let's get in there and see what we can do. Right, that's all connected in. Let me show you. So the cable comes from here to the BMS CAN, and then the power from the Cerbo now goes all the way down and connected into there. So we should be able to turn the batteries on now, and hopefully the Cerbo will light up. I've got it connected via standard Ethernet lead to the network. So let's turn it on and see what happens. Hopefully this works, or I could be going to the moon any second now. So let's see if we can connect to it. I'll run a few tests and I'll let you know. Okay, so that was it. Batteries are connected, control unit, the Cerbo is now connected to the batteries. So I've just registered it with Victron online portal. Took about 5 minutes, super easy. And I've just quickly set up the system and integrated it into Home Assistant very quickly and very easily in less than 5 minutes, just by making a web page card for the console, remote console. I just quickly added it here so we can look at what's going on. Nothing, because nothing's connected other than the batteries, which are at 50%, and then hopefully we should be able to go into it and see all the details of the batteries. So not only that, we can just go through the various options. Hold on, let me back to it. So this eventually will be integrated into the wall screen, probably somewhere here, so I can see what's going on eventually, but I'll put it on a separate page for now so that we can look at what we're doing. So the only things available at the moment are the batteries and the settings for the control unit, and that's it. We can go back to that and see that there's no, it's not connected to anything, there's no loads on, there's no multiplus connected at the moment. It's just literally to get it on the board and get it rolling, so to speak. That's it for today. I'm gonna do some other stuff and then I'll see you shortly. Good morning. Excuse the noise, it's my robot upstairs cleaning. Just happened to be doing right above my head, which is great. Where are we at now? Today we've finished literally all the DC connections. I have actually moved the Victron charger from up there to over here, and that was, although it was within the manufacturer's recommendations of spacing, I was slightly concerned about heat, because this produces heat which goes upwards, and then they've got the charger as well, so the charger will be being fed warm air already preheated from the inverter. So I've moved that and I've put the DC charger over here, and I've wired in the battery connections to the distributor down there via a cutoff switch. So all the cutoff switch are around the distributors. So they're for the batteries, that's for the solar, so that you can isolate all the DC connections just from down there. I've got in some, I think I showed you on the last video, we've got in the lightning protection and the breakers for the solar panels, which won't arrive for another month at least. I've connected in the communications cables, and temporarily we've got the internet connection there as well enabled. So the DC charger, Victron US5000, is wired in via the VE CAN system, and because of that, a CAN bus is like a communications protocol, but it only works if you cap off both the ends with a resistor. That's what these blue little things there, one there, and you've got one in the top. So now this is connected up, all the DC connections are made. I've double checked all the torques on all the connectors in the distributor. So what we're going to do now is, like we did before, is turn on the multiplus, the Cerbo control system, and the solar charger. Even though there's no panels connected, you should connect the batteries first anyway, so it knows what voltage the system is and so on. So we're going to connect all that up, go into the web interface, see if there's any updates for the solar charger, see if there's any more for the multiplus or the Cerbo, and you can just get a feel for what it's going to be like. That'll probably be the end of the video, because the next stage is connecting in the AC wiring and the earthing, grounding. That's going to be a separate video on its own. So this is just the DC side. As soon as we get this up and running, let's see if there's any updates. Turn on now the connection to the solar charger. There we go. And some lights flashing there. and our control system's on, and you can tell it's connected to the internet. Okay, so now we're logging in via Victron Connect. This actually gives us a bit more flexibility, and we can look at more details of what it's doing. Really good stuff. I mean, Victron just is the best. So we've got a little warning here, probably for an update. Yep, there we go. Let's update that then. Right, let's have another look. Usually this happens. There's another update, which is good because they always keep updating their products. I can explain some of these functions later for you, but nothing we need to be worried about. Okay, so that was fairly straightforward. We just enabled the, turned it on, enabled the charger. It was immediately picked up by the Cerbo, and because it knows it's connected to these smart batteries, we just leave the Cerbo to do the charging and set up right like that. So we're now going to power up the multi-plus. Now what we do is turn on both connections, and then here we go, the switch on the front. That's it, simple as that. And then see, yeah, the multi-plus has come on, and it's drawing power from the batteries already to run the multi-plus. I'm going to do a quick run through of what everything does, as how it works in operation. I'll do that because it was requested. I think it was by Sean. Thank you very much. So you can get a feel of what it's all there for and how it all works. So you get an idea of what situations it can be used for. Okay, so we're going to imagine that we have solar panels on the roof. Two lines. One is a row of 10, all in a line, all connected in series. That comes down into this box, through the lightning protection, through a disconnector. It goes across and into this Fronius. This takes the panel energy and turns it into alternating current, and that gets used in the house before you pull any electricity from the mains, providing it's sunny. And that is actually just a standard solar panel residential setup. So just that there, the protection and the on-off, and the solar panels, that's just what you would normally get for a bog standard, for a standard installation on a house. That can deliver 5 kVA. I was going to say kilowatts, but it's 5 kVA. I'll say kilowatts actually, yeah, that's 5 kilowatts. So you can use anything in the house as long as it's sunny, up to 5,000 watts. So that could be an oven, washing machine, all those things that are generally power hungry, water heater of course, tumble dryer, you name it. You can even charge your electric car using a normal plug socket charger as well. Some other chargers you can regulate the wattage, so if you set it below 5,000 it will charge your car as well, and you won't take any money from the grid, so you won't pay anything for the electricity. That's if it's sunny, obviously. Right, so why do we need all the rest of this? Okay, moving on from that, we want to store some energy in batteries. So that's what these are, lithium ion batteries. They're all connected together to form one giant battery, and you can store 19.6 kilowatt hours of electricity in the batteries. And with these particular ones, you can actually discharge them quite low, so that's quite a lot of usable energy as well that it will give you. So let's say, I don't know, 18 kilowatt hours. But the problem is, this inverter here, if it's not sunny, it won't work. If there's a power cut outside, it will automatically, as a safety feature, cut itself out. So that if someone's working on the line, you're not going to electrocute them when it's sunny. So, and at night, of course, that becomes completely useless because there's no sun. So what do? We take energy from the batteries and we have a separate inverter. This then produces the electricity from the batteries at night or when there's no sun. The electricity then goes into the house and it gets used first, similar to that inverter, but it can do it at night using the batteries or when there's no sun, obviously. So what are the rest of the things? They're all just ancillary things except for the solar charger up there. So why do we need two solar chargers? Well, there's two reasons for having this. One is that's just dedicated really to charging the batteries. For example, if I use the inverter at night, multi-plus, and I run it down and it's very low, in the morning the sun comes up, immediately as the sun comes up, that then starts putting energy back into the batteries. But I might then use something in the house, washing machine or whatever, but that just dedicates putting the sunshine back into the batteries. I can then use this at the same time from the other set of panels, so there's two sets, remember, to power the stuff in the house. So that continues to charge and it doesn't draw off the electricity to run your appliances during the day. So this will then continue as it's sunny, and that will power all your household loads. Well, that one is dedicated to charging the batteries. That's just the protection from the solar panels, so that if it gets struck by lightning, it goes straight to earth, and you can isolate each set of panels. This is the brains of the operation. It's what provides the interface, and it also takes care of the charging of the batteries. It also communicates with the inverters, and when there's no need for any of these inverters to be running, it ramps them down or turns them off. Down the bottom right there is just a crossover, a changeover switch. So if I wanted to connect a generator as well, I could do, instead of using the mains, but that's for further down the line. You've already seen those two on-off switches for the multi-plus, the on-off switch for the solar charger. So you can see the cable comes down into there and then up into the battery bus bar, and that's all they are inside the distributor, just metal bars where you can put fuses in, so they're all fused as well, and it connects your appliance, your inverters to your batteries using, because they're really thick cables. So there we go. That's a brief run through. One of the things we have got, which might be on the next video or a separate video, is the Victron electric vehicle charging station. I've just got to find a location for it. Once I find a location for it, we'll get it set up and connected in. So that's it for this video. Any questions, comments, leave them down below. I'll try and answer them. Yeah, that's it really. It's quite straightforward. In principle, some of the settings is complicated, but anyway. Don't forget, if you like this, you can always buy me a coffee. Link in the description. And head over to French Ear Trumpet that I do with Colin, where we just discuss all sorts of stuff. Anything from vehicles to living in France, all that kind of stuff. It's quite funny. Really enjoy making them. So there you go. Hope that made sense, and I'll see you on the next part.